Hello and welcome back to the channel. In this video, we're going to be looking at logical operators in Java. In the last two videos, we already looked at arithmetic operators and relational operators. Now there, I told you that arithmetic operators and relational operators are quite simple because you use them in your daily life. Logical operators, however, are a bit different and might be something new to you. In Java, there are three main types of logical operators. The first operator we're going to be looking at is the OR operator. Now, before we look at how we can implement the OR operator in an actual program, we'll first have to understand what the OR operator exactly does. To do this, we'll look at this simple expression over here. Here, the two standing lines represent the OR operator. So you can read this as A or B. Basically, the OR operator evaluates the whole expression to a true if one of the expressions is a true. In this case, A and B are both Boolean expressions, meaning they are expressions that evaluate to a true or a false. So let's say that A is the expression 3 is greater than 6 and B is the expression that 5 is not equal to 8. You notice that we're using relational operators here because relational operators always evaluate to a true or a false. In this case, 3 is greater than 6 is obviously false, and 5 is not equal to 8 is obviously going to be true. Understanding our OR operator is going to tell us what the final output of the whole expression is going to be. To do this, we're going to be looking at what's called a truth table. Basically, in a truth table, you're going to be looking at all the possible inputs and all possible outputs. So we can start with one possible input where A is false and B is also false. Remember, I told you that the OR operator evaluates an expression to a true if one of the inputs is a true. Here, since both our inputs are false, A or B is going to evaluate to a false. Then you could have an expression where A is false but B is true. Again, the OR operator evaluates an expression to a true when either one of the inputs is a true. Since B is a true, A or B is going to be a true. We're going to notice the same thing when we take A as true and B as false. Since A is a true, one of the expressions is a true, and therefore A or B is going to be true. And what if A is true and B is also true? In an OR operator, any one of the expressions has to be a true. So even when both the expressions are true, A or B is going to evaluate to a true. Now we'll look at this expression again. Here we notice that 3 is greater than 6 is false, but 5 is not equal to 8 is true. When you're using an OR operator, I told you that either one of the expressions or terms must be true for the whole thing to become true. In this case, since our second term, 5 is not equal to 8, is true, this whole thing is going to evaluate to true. Now we're going to look at the syntax for the OR operator. Now, like I've shown you before, when you're using an expression with an OR operator, like this expression, which basically means A or B, these two standing lines represent the OR operator. Now, you might not have used these standing lines before. On your keyboard, it's often located above the enter key. Now, let's look at this expression where I'm basically using the OR operator with these two terms over here. Now, we don't always need a bracket around the terms, but it does help to differentiate the OR operator and other relational operators. In this case, one of my terms is basically if 2 is greater than 5. That's obviously going to be false. 2 is not greater than 5. This term is basically 1 is less than 3. 1 is less than 3, and therefore this term is going to be true. When we have an expression of the form false or true, remember an OR operator evaluates the whole expression to a true if one of the inputs or one of the terms is a true. Since this is a true, this whole expression would be true, and therefore our boolean variable a is just going to store true. We notice this when we print the boolean variable a as well. When I run this program, you notice that it's just going to print true. This whole expression is going to be evaluated to true just because we're using the OR operator. Now if I change this to something like 1 is equal to 3, here this expression is false and this expression is also false. Since none of our inputs or none of our terms are true, this whole thing is going to be evaluated to a false. When I run this program, you can notice that it's just going to print false. The boolean variable a stored false and our println statement basically just printed false. Now one important thing is that in an expression, I can add more logical OR operators and add more expressions that evaluate to a true or a false. So over here, after this expression, I can add another OR operator and I can add something like 2 is greater than 1. And I can keep doing this. I can keep adding more expressions. I can add another OR operator and I can add an expression like 3 is lesser than 5. Now this might look a bit confusing, but this is the same as adding multiple numbers. When you add multiple numbers, you're just using the additional operator again and again and again. That's the same thing that you're doing over here. To evaluate this, you can just look at every OR operator. If you look at this OR operator, it has these two expressions. 2 is greater than 1 and 3 is lesser than 5. 2 is greater than 1 is true, and 3 is lesser than 5 is also true. Remember, since one of the expressions is a true, this whole thing is going to be evaluated to a true. So I can just replace this whole thing with a true. Then I have this expression. 1 is equal to 3 or true. An OR operator evaluates to a true if one of the inputs or one of the expressions is a true. Even though this is a false, since this is a true, this whole thing would again evaluate to a true. And similarly, this whole expression would finally evaluate to a true. So we notice that in an expression involving multiple OR operators, if one of your expression is a true, the whole expression is going to be evaluated to a true. To show this, I can just print the variable a. When I run this program, you notice that we're going to get our output as true. Because this expression is true, this whole thing was evaluated to be true. Now I just changed two of these expressions. I made this expression false, I made this expression false, and I kept these expressions as they are. Here, all expressions are false, and therefore this whole thing would evaluate to a false. When I run this program, you notice that we are going to get false as our output. Now we're going to be looking at the AND operator. First, we'll try to understand how the AND operator works. So we look at this expression over here, which you can basically read as A and B. The double ampersand represents the AND operator. An AND operator evaluates the expression to true when both the inputs or both the terms of the expression are true. In this case, we can consider A and B as our expressions. Let's say A is something like 9 is greater than equals to 2, and B is something like 2 is equal to 1. Both of them are expressions that evaluate either to a true or a false. Our first expression is a true, and a second expression is obviously a false. 2 is not equal to 1. So then how do we determine if our whole expression is a true or a false? First, we look at the truth table for the AND operator. So in this truth table, you can notice that we have our column for the possible values for A, the possible values for B, and finally the output of A and B. If A was false and B was also false, A and B would be false. If A was false and B was true, an AND operator evaluates to true when both the inputs are true. That is, when both A and B are true. Since A is false, this expression is going to evaluate to a false. Then we're going to look at an expression where A is true and B is false. Even though A is true, since B is false, this whole expression A and B is going to evaluate to a false. Finally, we can have A as true and B as true as well. When you take A and B, since both our inputs are true, the whole expression A and B is going to evaluate to true as well. Now we look at our original expression again. Here we have 9 is greater than equal to 2, which is obviously true, and 2 is equal to 1, which is obviously false. Remember, for an AND operator, both the inputs or both the expressions have to be true. Since 2 is equal to 1 is false, one of the inputs is false, and therefore this whole thing is going to evaluate to false as well. Now the symbol for the AND operator is just a double ampersand. You can locate the AND symbol above the 7 on your keyboard. So now let's just create a Boolean expression using the AND operator. We'll make a variable called D, and we'll use booleans directly instead of using relational operator expressions like we did before. If we say something like false and false, in this case, since both our inputs are false, this whole thing is going to evaluate to false, and that false is going to be stored in this variable D. When I print this variable D, you notice that we're going to get our output as false as well. Now if I make one of these expressions true, even though one of the expressions is true, since the other input is still false, this whole thing would evaluate to false, and printing the variable D is just going to print false again. When I make both expressions true, however, since both the inputs are true, this whole thing would evaluate to a true. When I run this program, it is going to print true. And like we did with the OR operator, you can use multiple AND operators in a single expression. Here I have multiple expressions connected using just AND operators. We can simplify this whole thing by looking at each AND operator. If you look at this AND operator, You notice that it's connecting this expression 2 is greater than 5 and 1 is lesser than 5. This is true. However, this expression is false. Since one of our inputs is false, this whole thing would evaluate to a false. Even though this term is a true, since this expression is a false anyways, this AND operator would evaluate the whole expression to a false. When I print the variable d, we do indeed get false as our output. Now to make this a bit harder, I added an OR operator in the expression as well. Let me just copy this expression and try to evaluate it. Over here, 1 is greater than 5 is just false. So I can just write down false over here. The second expression, 2 is lesser than 5, is obviously true. Remember, when we use an OR operator, either one of my inputs has to be true. Since this input is a true, this whole thing is going to be evaluated to a true. 1 is not equals to 3 is also true. So I can just replace this with a true. 5 is greater than 2 is also true. So I can replace this with a true as well. Since all our inputs are true, this whole expression is going to be evaluated to a true. When I run this program, you will notice that we do indeed get true as our output. Finally, we're going to be looking at the NOT operator in Java. Now, if you remember the video on relational operators, I told you that NOT in Java is represented using an exclamation mark. So even when we use NOT as a logical operator, we're using an exclamation mark. A NOT operator simply changes a true to a false and a false to a true. It basically inverts the input. Over here, if I have an expression that says NOT of C, if C was true, it would evaluate the expression to a false, and if C was false, it would evaluate the expression to a true. Even though this is simple, we can look at this through a truth table as well. If I look at this truth table, we have one possible input where C is false. NOT of C is just going to be true. C could also be true. In that case, NOT of C would just be false. To understand the NOT operator, we look at this expression over here. We basically have NOT of 5 is greater than 6. First, we'll try to evaluate the expression 5 is greater than 6. 5 is definitely not greater than 6. Therefore, this expression is going to evaluate to a false. When you use the NOT operator, you're basically changing this input to a true. So NOT of this false would basically change the whole expression to a true. We'll look at another expression. Over here, I'm using a NOT operator and an OR operator as well. If you look at 9 is greater than equals to 2, 9 is definitely not equal to 2, but 9 is greater than 2. So this is going to be true. And then we have another term which is basically 2 is equal to 1. 2 is not equal to 1, so this is going to be false. When I'm using the NOT operator on this expression 9 is greater than equals to 2, it's going to change this true to a false. Now this looks too clumsy, so I can simplify it by just writing the Boolean equivalence. I can just write this as false or false. We know that when we use an OR operator, either one of the inputs has to be a true for the whole thing to be a true. Since both our inputs are false, this whole thing would evaluate to a false as well. You already must have understood the syntax of the NOT operator. When I have a Boolean expression that evaluates to a true or a false, if you want to invert this or if you want to use a NOT operator, you just add the NOT operator before the expression. Over here, I'm going to add brackets around this expression so that we apply the NOT operator on the whole expression, and I'm going to add an exclamation mark before the expression. Here, 3 is greater than 5 is obviously false. The NOT operator is going to turn that false into a true. And when I print the variable b, you notice that we are going to get true as our output. Now, why do we need these brackets? If I remove these brackets, you're going to notice that it's going to cause an error. This is because the NOT operator always acts on a Boolean. 3 is greater than 5 evaluates to a Boolean, so we can use the NOT operator on the whole expression. Here, when I remove the brackets, Java is trying to use the NOT operator on the number 3. I can't use the NOT operator or any logical operator on something like an integer or a double. Finally, we look at this expression, which is a bit different. Here I have two terms, 9 is greater than equals to 2 and 2 is equal to 1. And I have an AND operator connecting the two terms. Now notice that there are brackets around this whole expression. This means that I will have to evaluate this whole expression first. It's either going to be a true or a false, and then I'm going to apply the NOT operator on the final output. We'll look at the first term. 9 is greater than equals to 2 is obviously going to be true. And in the second term, 2 is equal to 1 is false. 2 is not equal to 1. I can write this as NOT of true and false. Now we'll have to evaluate this expression inside our brackets. We know that when we're using an AND operator, both our inputs need to be true for the final output to be true. Here, since one of the inputs is a false, this is going to be a false as well. Not of this false is just going to be true. So where we have our brackets is going to change the output as well. You have to be careful when evaluating expressions using logical operators. And that's it. That's all you need to know about logical operators in Java. Thank you for watching and have a great day.